With this segment, we're going to learn how to do our same exact special angle problems that we've been doing before, only we're going to do them in radians instead of degrees. But before I can do that, I probably need to have you go on a little bit of a visit back to the radians we learned a few days ago. In particular, I want you to remember, if you're thinking about the clock, that 0 radians is still at 0 degrees. 180 degrees is pi radians. Therefore, straight up is half of pi, and straight down is 3 halves, or in other words, 1 and a half pi's. What we need to do is also alter our special angle table. So I'm going to go over here to the special angle table, and we've noticed we've got another column called radians. And we have to figure out 0 degrees is how many radians. Well, if you have no degrees, you also have no radians, so that's 0. But the rest of them will turn out to be pi divided by some number. If you'll recall, when we were converting units, pi is the same thing as 180 degrees. So in order to get 30 degrees, ask yourself, what do I have to divide 180 by to get 30? Well, hopefully somebody out there has saved 6. So the next one, to get 45, 180 would be divided by 4. To get 60, I need 180 divided by 3, and to get 90, I would need to get 180 divided by 2. Okay, most of my students, after they use this, get them learned, but some of them did notice it goes 0, then 6, 4, 3, 2. So if you kind of remember the pattern, it helps, but you really will work with them enough that you'll probably get them learned with no problem. Okay, we're going to work the exact same kind of problems that we worked before, only we're going to do them in radians. So we're ready to continue, and what we're going to do here, sorry, there was a brief pause in here and an interruption. We'll try again. We want to try to find out what the tangent of 7 pi over 6 radians is. Now, this is just like you did with degrees. You have to do 3 things. You have to find the quadrant, find the reference angle, and then determine the value of this particular angle. So, in our case, you have to remember from a few days ago, how do I find out where 7 pi over 6 radians is at? If you recall, we would change it into 1 and 1/6. Okay, that means you have 1 pi and a 1/6 more. So 1 pi is halfway around or over to the 180 line. Now you're going to do a 1/6 more, and you need to ask yourself, will I go past the halfway vertical line down here? In this case, no. I'm going to stop just a little bit into the 3rd quadrant. So that tells me I have a 3rd quadrant angle. Now here's the good news about doing radians. Since I know that was 1 and 1/6, that means I went an angle of 1/6 past, or in other words, an angle of pi over 6 when I went past that. So my reference angle here is pi over 6. All you have to do to get your reference angle is look at the number on the bottom of your fraction. There's a 6 on the bottom here, so you know you're doing pi over 6. So now we go to our chart, and we look up, okay, I need the tangent. Pi over 6 is the 2nd row down. Go over to tangent, and I'll discover my value is square root of 3 over 3. So since my value is square root of 3 over 3, the only thing I have left to ask myself is, should it be positive or negative? Well, since I'm in the 3rd quadrant and checking out All-Star Trig class down there, tangent is positive in the 3rd quadrant, so this would be a positive square root of 3 over 3. Okay, let's try a few more. Suppose I had asked you to find me this time the secant of 3 pi over 4. You would ask yourself, well, where is 3 pi over 4? Well, that's 3/4 of pi. That's not even a whole pi. So we haven't even made it over to the 180 line yet. But 3/4 is more than half, so therefore we know we're past the vertical line and we're headed into the second quadrant. I know my reference angle because I know there's a 4 on the bottom of this fraction, so therefore I know I'm using pi over 4 as my reference angle. Now I need to know secant, and secant is, of course, the reciprocal of cosine. So I'm going to go look up the secant of pi over 4, which is the third line down, middle column, and I'll discover cosine square root of 2 over 2. So if I want to do secant, I have to turn that upside down. And if you remember the other day, we rationalized these, but I did show you a shortcut for this one, which I want to point out again. When you rationalize it, the 2's will cancel and you'll just get square root of 2. So if you are doing a reciprocal of square root of 2 over 2, it becomes square root of 2. If you're doing the reciprocal of square root of 3 over 3, it becomes square root of 3. Now, the last thing I need to do is I need to check for positives and negatives. Since I'm in the second quadrant with a secant, I see that it's not listed down here in the table, so I know that it's got to be a negative square root of 2. Okay, one more here. Suppose I was to ask you for, this time, the cotangent of 3 pi over 2. Okay, cotangent, we'll deal with that in a second. First, we've got to figure out where's 3 pi over 2. Okay, hopefully you'll learn after you work with this table a little bit that anytime you see a 2 on the bottom of the fraction, you'll know you're down on the bottom line with the pi over 2. In other words, you're on a quadrant line. 3 of pi over 2 is really the same thing as 1 1/2 pi's. So if I go to my chart here and I go 1 1/2 pi's around, 1 1/2, that means I'm sitting here on the bottom quadrant line. Okay. I can go then, I know it's going to be pi over 2, there's 2 on the bottom. I can go over here to pi over 2 in the table, and if I'm doing cotangent, I have to first look up tangent. Well, it says tangent's undefined. How do you do the reciprocal of undefined? Well, you have to remember, to be undefined means you have some number divided by 0. So if you do its reciprocal and flip that over, you'll get 0 over 1, or in other words, 0. So in our case, our answer is 0. You don't have to worry about a positive or negative if it's a 0. Now we're going to practice this some more with this next problem I have lined up. This next problem looks like it could be a real doozy. That's a lot of different terms in one problem. I am actually wanting to work out 5 different trig functions on this one. But this will give us great practice because it has about every possible wrinkle in it that it could have. So we're going to start out in the top left corner. We're going to figure out the cosine of 11 pi over 4. Now hopefully you'll remember that that little squared up there simply means that once we get this worked out, we will square that answer. So I first need to go, okay, where is the cosine of, or what is the cosine of 11 pi over 4? Where is 11 pi over 4? That's kind of big. If you divide 4 into 11, it goes in there twice, which would be 8, and has a remainder of 3. So it's 2 3/4 pi. So where's 2 3/4 pi? Well, 1 pi is halfway around, 2 pi is all the way around, and if I go 3/4 more, I'll be past half, so that lands me in the second quadrant. Now, the good news is I know my reference angle easily. Since there was a 4 on the bottom of the angle, I know I'm going to use pi over 4 to look this up. So I'm going to my chart, and I'm looking up the cosine of pi over 4. So if you go down to the third row, get in the cosine column, you'll discover that cosine has a value of square root of 2 over 2. Now, technically, in this case, since it's in the second quadrant, it should be negative. But because we're going to square it, you really wouldn't have to care on this one, because we know it will come out positive when we square it. Okay, the next one, you'll notice we have 2 trig functions beside each other. which means that they are actually supposed to be multiplied. So when we get these two numbers, we're going to multiply them together. Okay, the first one is a negative 4 pi over 3. Well, 4/3 is 1 1/3. The negative tells me I need to go backwards 1 1/3. So I would start at my usual positive x-axis, go backwards 1, which would be halfway around, and then another 1/3, which would put me somewhere in the second quadrant. It has a 3 on the bottom, so I know pi over 3 is my reference angle. And I need to look up the cosecant of pi over 3. Well, cosecant is the reciprocal of sine, so we need to go down to the sine of pi over 3, which is the second line up from the bottom, and discover we're going to get square root of 3 over 2. So we need to do the reciprocal of that, which will make it 2 over the square root of 3. At this point, I recommend you don't rationalize them, because particularly where we're going to multiply it by another number, it may work out that the square root of 3 cancels or multiplies with something else. So leave it for now. We can always rationalize it later. The other thing you need to, of course, check for is all-star trig class, and in this case, cosecant is positive in the second quadrant, so that is a plus there. Our third one, the tangent of 11 pi over 6, we're going to go, okay, 11/6, that's 1 and 5/6, so that's almost a 2 pi. So we know 1's around, 5/6 would definitely be more than half. I'm in the fourth quadrant, and I have a pi over 6 as my reference angle. So all I need is the tangent of pi over 6. Checking out my table, second row, tangent column, we'll get square root of 3 over 3. Now, is it positive or negative in the fourth quadrant? Hopefully somebody out there is shouting, it's negative. Now, we will come back in a little bit and simplify all the numbers here. For right now, I just want to get them evaluated, then we'll worry about the algebra to simplify them. So we're going to move on down to the denominator. Okay, this first denominator is the sine of 3 pi over 2. Well, that's 1 1/2 pi's. So I'd be going 1 1/2 more, put me at the bottom. So once again, it's on a quadrant line. I know there's a 2 on the bottom of the fraction, so I know I'm going to use the pi over 2 value. So if I go down to the very last row in the sign column, I'll discover it takes on a value of 1. But here's the wrinkle. How do you know if it's positive or negative? It's on a quadrant line. Hopefully somebody's saying, but we're on the negative side of that line. We're down below, so therefore it needs to be a negative 1. And that would be correct. Okay, plus then, last one, 17 pi. That's a lot of pi. How are we going to figure out where 17 pi is located? Well, 17 pi, that's whole pi's. We know 1 pi is halfway around, 2 pi is back to the beginning. 3 pi is halfway, 4 pi is back to the beginning. If you notice, 5 pi is odd, we're on the left. 6 pi is even, we're on the right. So anytime we have an odd number of pi's, we're going to end up on the left. So this problem ends up being over here on the left side of the axis. Now I'm on the same quadrant line as 0, so therefore I'm going to use 0. I'm going to go look up the cosine of 0. 0 radians. Cosine, I'll discover, has a value of 1. And then because I'm on the left side of the axis, it's got to be negative 1. All right, it looks like we've completed our calculations. All we need to do is add this thing up. So if I square these numbers, squaring this first one, square root, you'll get 2. Square the bottom, you'll get 4. That's a half. Plus, on the next one, when we multiply, the square root of 3's cancel. So I am left with just a negative 2/3 all over negative 2. And last but not least then, if I do a little 5th grade math, 3/6 plus negative 4/6 divided by negative 2 is negative 1/6 divided by negative 2. And if I do the reciprocal of that, I'll end up with positive 112.